How many people here calibrate their own displays? Okay, we got one in the front. We got one in the front. All right, how many are going to calibrate their display after today? All right, we got a few more. All right, that's great. All right, well, we'll get started here. So if you're like me, when you calibrate, it's all about quantifying what we're doing, what the monitor's doing, how accurate's that monitor, of course calibrating it if it's not accurate, and of course validating that you're hitting your targets, that you're getting the results you want. So whether you're working in, let's say BT709, Rec 2020, BT 2020, HDR, we want to know from the lens to the living room, is my creative intent getting all the way to the end here? And of course, today we're going to talk about the monitor. Okay, so who is Portrait Displays? Well, Portrait Displays is a global company that currently has offices in all these beautiful places, and we make calibration software, such as Calman, which we'll go over today, and we also make some white label software that you might know about in certain products that calibrate themselves, and we also have a calibration as a service business in Europe and in Canada, where people will use our software to calibrate monitors for customers as a service. And what do? So we integrate into monitors, TVs, notebooks. We're actually working, if you haven't heard about it, with MediaTek on the Pentonic chip, and we'll talk a little bit more about that later with our Calman powered and Calman Ready programs. And then we've got our calibration software with our validation, our calibration, and our LUT engine called the Aurora Color Engine. So why do we calibrate? As I mentioned, calibration is all about getting that consistent color from the lens to the living room and making sure that the artist's intent, whoever's creating the content, and I assume everyone here is pretty much working in the creative space since we're at NAB, is getting that intention all the way to the customer for their enjoyment. One of the things that comes up a lot with our customers is, I'm using an OLED, I'm using LCD, I'm using a quantum dot. How do I make sure these match? How do I make sure these are hitting their targets? How do I make sure that, if one is a little blue, that's the right blue, or is that a little blue, right? And so that's what calibration is really about, is ensuring that integrity throughout the path and throughout creating content, because it's all about the story, right? We're all trying to tell a story, we're all trying to get that emotion across in our content, and calibration is a big part of that. So when we calibrate, we have to have a metric. So typically, the most common metric we've used in the past is delta E, or delta E2000. Now in HDR, there's a metric called delta ITP. And here we're talking about delta E2000. So we're going to measure a color, and we're going to compare that color to where it should be, and then what is that error? Now, you might have a high error, which will be dramatic. You might have a lower error, which might be subtle. But it's not just about the error, it's also about setting your levels, setting your ranges, setting your color space, and we'll go through that a little bit here. So if you have clipping, you might be losing some of your white detail, right? If contrast is set too high. If you have your brightness too low, you might be crushing your black level, losing some of these details you might see in this test pattern here. If you have, there we go. If you have your colors, yeah, there you go, thanks. Oh yeah, that's better, thanks. If you have your color space or your color gamut set incorrectly, you might not be actually mapping the color you think you're mapping, and you're going to clip your color and you're not going to get the saturation you're looking for. Or if you're creating content and you're working on a monitor like this, you might start to push color out more, and then of course when it gets mapped properly, it's then going to be even more saturated because now it's being pushed out all the way on someone else's monitor that is properly set up. And then of course, if you are working on content, and this is a sharpness pattern, if you're working on content and the image is being sharpened by your display or your system, you might soften it, and then if it goes onto a calibrated monitor, it might look extra soft, or vice versa. If it's soft on your monitor and then you add a lot of sharpening in your grading session, your content creation, you might find that now it's over sharpened. Gosh, really sensitive here. I think I lost it. Do you have what's this? You got it? I can just hit an arrow if you want. Thanks. So here is an example in an ASUS monitor where ASUS has put together a lot of standardized color spaces that we might use in production, such as HDR, PQ Rec 2020. And I love this about monitors in general. Any monitor that's going to tell me exactly what I'm working in, absolutely love it. You might see a lot of displays in the world that say Vivid or Game. Doesn't really tell you how it's calibrated, how it's set up, what you're working and what you're doing. But of course, even if you go to some of these modes that aren't right, you might have a mismatch in your calibration. So it's very important to make sure that your calibration setting is matching the mode you want to achieve. If you're trying to achieve HDR and HLG with a P3, you want to be in that HDR, HLG, DCI color space. So we have two major programs with portrait displays in terms of monitors that ASUS is a part of. The Calman Verified program we'll talk about here in just a second, and then the Calman Powered program, or the Calman Ready program, which we'll be showing the Calman workflow today for. Of course, what is Calman? Calman, of course, is the de facto standard in Hollywood for color calibration. It's all about measuring, like I said before, quantifying, calibrating, and validating your displays, bringing color accuracy, reporting, speed and efficiency to the process. Calman Verified. Calman Verified essentially means a manufacturer is calibrating their display to the standardized targets that we use here in Hollywood. Companies like Netflix, Sony, Disney, Pixar, the same standards they're creating content, these monitors are being calibrated at the manufacturer before they arrive, and they're coming with a calibration report to let you know this is how it measured, this is how well it is. Now, how do we justify something being Calman calibrated? Well, we look at that delta E metric that we were talking about before. How far off is the calibration from our target? Keep in mind, a delta E of 0 is considered perfection. A delta E of 10 would be an error of 10. The larger the error, the more you're going to see there's an issue with your calibration. So Calman Verified display has a delta E of an average, it should be about 2 or under, with a max no more than 4. Typical monitors, even in the best of broadcast monitors, we don't usually hit 0. And there's a lot of reasons for that. Some of that's just the meter tolerance. If you've ever used a light meter, you'll notice most of the specs will say plus or minus 1%, plus or minus 2%. So you get some variations in the meter. You'll get variations from power and stability, heat and cooling. And so most monitors, even the very best, aren't really going to have a delta 0 across. In fact, 22 years of calibrating, I've never seen a monitor that has 0 across the board. Moving on, we talked about the delta E scale, 1 being a just noticeable difference, 2 barely perceptible, 2 to 5, and then 6 to 10 being extremely drastically different. And our Calman Verified displays are a delta E of 2 or under on the average. So Calman Ready. At a glance, the Calman Ready program brings about a very efficient, speedy process to achieving your goal. Right now, or I shouldn't say right now, but in the past, you had to be a color scientist to perform a calibration. You had to know all these details about color spaces and gamuts and ranges and conversions, LUT scaling, LUT formats, etc. Calman Ready program tries to make that very easy for the user where anyone can calibrate their display. What do you want to do? Let's show you how to do it, and let's make sure you got there. We do that through a Calman Universal Interface, where the computer talks to a light meter, talks to the display, talks to the generator. I'll go over that a little more as we move into the actual process. And we're on to our PA32DC ASUS monitor. So, when we want to calibrate the PA32DC monitor using Calman Ready, you're going to want a light meter. We're showing here our C6 colorimeter. We've got Calman running on a PC. And we connect that to the monitor by connecting the meter through the USB, and we can connect the monitor. We can connect the monitor as well through its interface to the computer. You can also use the monitor. The PA32DC actually has a built-in test pattern generator that we integrate with, so you don't necessarily need an external generator. But if you'd like to use an external generator, you certainly can. So SDR. Has anyone gone through this process on their own yet? It seems like we had one gentleman in the front that has calibrated before. You have, okay. All right, well, if you haven't gone through it, but you have any questions during this, feel free to raise your hand. I'll try to answer it as we walk through it, because I know I'm going to kind of go through this a little bit quickly here for everyone, because it's quite a process. So we have our ASUS monitor calibration in our Calman Ready workflow. User can hit start calibration. It's going to walk you through the entire process here. So you're going to connect to your hardware. We talked about how you'll need a light meter, you'll need a pattern generator, and you'll need the monitor. So we can hit find meter, and it'll bring up a process of working with various meters. Now, one of the great things about Calman versus a lot of other software that's out there is we actually integrate with a vast amount of meters, from Konica Minolta, Photo Research, X-Rite. We work with just about any meter. It's one of our things. We don't want to really be specific to a specific company or a specific meter. We want you guys to work with the equipment you trust and that you want to work with. So if you want to work with that Photo Research, we'll support. You want to work with the client, we'll support it and help you achieve that goal. Same thing goes for the pattern generators, which we'll get into in just a second. So we've connected to our meter. Now you want to set up your meter. This is a big pitfall for a lot of people I know that try to calibrate. Once you connect to your light meter, the light meter itself may have some settings, right? It might have sync, it might have a color profile. So on our C6 meter that we're using in our demo here, you'll notice in Calman we choose a meter mode for RGB, because this is an OLED RGB monitor that we're using. And what that is we're doing a corrective calibration of the meter to make sure that the meter is properly calibrated for the spectral response of the monitor itself. Different monitors, LCD, OLED, xenon lamp projectors, laser-based projectors, they all have a different spectral power distribution. And when we calibrate, we need to make sure that the meter is actually optimized for that spectral power distribution so that we get the right result from that monitor. If you're not choosing the right meter mode, you may have some error introducing some of those delta E's if you then tried it later with the right meter mode into your process. It might be one of the reasons why monitors might not match, or you might not be seeing what you're expecting to see. And then on this meter, we left it in auto sync, but sync is also very important. If you're running at 24 frames a second, you're running at 30 frames a second, monitors may also change their performance based on it. They might sync at different refresh rates. You'll want to make sure you're synced to the proper rate when you do your calibration so that you don't run into those meter pitfalls. So typically, again, you're going to connect to your meter, you're going to choose your offset profile if you need to on whichever meter you're using, you're going to set your sync, and you're going to move on to the next step here in terms of finding the monitor. So here we are finding our monitor. You choose your ASUS monitor, and I did the 3D LUT workflow process during this workflow here. You'll notice also that in Calman there's these modes in the top right corner here. This is your meter, then you have your generator, and you have your monitor. And that's where all your settings are going to be if you're going to try to calibrate your monitor. If you want to go to the monitor and you want to change any settings inside Calman, you can just click up here. The green means that we're connected. And next step here, we're setting our levels, PC, 0 to 255 I was working in during this calibration process here, so I set the monitor and the generator to PC 0 to 255. And of course, we're finding our generator next. So we've got our meter connected, we've got our monitor connected, we go to our generator, and I'm gonna actually use, in this workflow, we're using the SpectraCal Video Forge Pro, but we do work with the ASUS internal generator, so you can use that as well if you don't have an external generator that you'd like to work with. Following our connecting to our monitor, our setting up our meter, we're going to set our targets, right? So what are we working in? Typically, in an HD workflow today, we're working in Rec 709, BT 709 at a 2.4 EOTF. So I've set up this workflow to be D65 3127 3290, color space of Rec 709, and the EOTF A-Power 2.4. And in my AutoCal Delta E formula, this is actually a setting within Calman for us to calculate the amount of error. So how much error is acceptable to you? So I actually set this to Delta EITP because that's actually a harder metric. That's a new metric, harder metric, and it means Calman is going to work harder when it builds its LUT to give you the least amount of error throughout the process. Either way will work great. If you want a faster calibration, use Delta E2000. It's not going to try as hard, it's going to go a lot quicker. So let's say you're on set and you just got to get some monitors in the ballpark while you're shooting your content and you're like, I don't have all day. Sometimes that happens, right? You can use that Delta E2000. It's going to go through it nice and quick. It's going to give you a really, really good result. Delta EITP, going to be that little bit better, but it's going to take a lot longer. And by a lot longer, we're talking about a few minutes, not hours or anything. We'll do a pre-calibration capture because it's always really great to know where the monitor is as you're starting to work with it. Now keep in mind, if you measure a monitor with different meters at different times, you may find some error between them, right? Because the monitor has to warm up. the meter has to be calibrated properly for the monitor. And meters have tolerance. So here when we did this measurement, you'll notice it was going a little red on the bottom end, our grayscale from 0 to 100. Our EOTF, which is our gamma tracking, was actually tracking very well against our target yellow line. And the color gamut in the mode I was in a wider color gamut than our 709 target in the corner there. On the ASUS monitor today, we integrate with two modes, two of the user color calibration modes. So your next selection is going to be, where do I want to put my calibration? Do I want it in mode 1 or calibration 2? Select your mode wherever you'd like to store the calibration, and then we're going to set our luminance. So in BT709, typically in a broadcast production environment, we're working about 100 nits, or I think it's about 29.2 foot Lamberts. So here I targeted just a little over that 100 nits because when you calibrate a monitor, you're correcting the monitor. And you can't go any further out, but you can come down. So anytime a monitor is going to be the brightest, a projector, a monitor, anything, it's going to be in native mode. Once it's in native mode, you can correct it down, but you can't increase light. It's already at its max, no corrected light. So I like to target a little bit above so that when I correct it, I come right where I want to be. So I targeted about 104.7 nits here by adjusting the brightness slider here in the bottom. And since we're connected to our monitor, one of the great things to know is that the brightness slider actually does adjust the brightness on the monitor, right? Because we're talking to that monitor through our Calman universal interface. So you'll kind of go through this iterative process. Measure, oh, that's 110 nits, okay, let me bring that down. Measure again, oh, that's 108 nits, okay, maybe I bring that down. If you're targeting brighter, set it brighter. Once you're done, you go to the next page, and we're gonna do what's called our AutoCal process. So AutoCal is gonna try and take that complexity out of the entire process for you, as I was alluding to before with Calman Ready. We wanna make this a very simple process, we wanna make it a very straightforward process. So our AutoCal 1D and 3D LUT here is gonna ask you to press the AutoCal button. And that AutoCal button is down here. This is how you control Calman pretty much for all your measurements. So AutoCal is this little icon down here. If you want to take a single read, you might use the play button. If you need to stop your read for some reason, someone opened a door, someone did something, someone tripped on the light meter wire if you're using a light meter on a tripod, you can hit the stop button down here. And it's going to then go through a process to do your 1D LUT, which is going to be your EOTF, calibrating it down to D65 or whichever target you looked for. And then it'll prompt you to do your 3D LUT. It'll do a 3D LUT, and then process essentially completed. Now we're not quite done. We do need to go to our verified luminance, because remember I said we lost a little. So I ended up measuring about 101.2 when I was done. So I lost about 3 nits. And at which point, if I want to go up or down, I can. And once again, I would adjust this brightness slider in order to do that and get it to the point where I would like it to be. Now, once I've got my brightness done, I've done my 1D LUT, I've done my 3D LUT, I've set my luminance, I should be good to go. So I'm going to take my post-calibration capture, and as you can see, we're now tracking a nice D65 across our grayscale, from black at 0% all the way to white at 100%. We're tracking our EOTF all the way through. We're doing about 101 nits, and we are hitting our color gamut targets here versus being oversaturated before when we were in an uncalibrated state. So in Calman, a lot of people would say that's done, I'm going to move on. But if you wanted to do a little more validation, right, because there's only so many metrics that we're looking at there, you can hit the additional validation and do something like the color checker chart to see how the gamut mapping has really come out across the board. I personally like to do this because I think when you just measure the edge of a gamut, it doesn't really tell you how your mapping's doing. Am I in the right space? Do I have a range issue? Did my LUT fail in some way? Do I have some kind of luminance error happening? So going through the color checker is a personal preference of mine. I highly recommend that you do it if you are working in a content creative space. If you just need to get it done, you can skip this part and trust that the process is been done. But I really do recommend going through this. And again, we've got our delta E's down to about a max 1.1 here with an average 0.6 after we've gone through our custom calibration process. And there's also a saturation sweep after the color checker to give you how your saturations are doing on the primary and secondary colors. And here we have a 1.7 max with an average 0.6. We have a little peak in that yellow, which I think I know what went wrong during my calibration because I was multitasking, but I think I had a little light leakage at one point, and that caused my little bit of yellow error there, but it should be similar to that one and done for the most part. And then what's really nice about Calman is you can export a report when you're done for that validation. If a colorist, if an editor, if someone's questioning, if someone wants to know what's going on, how's it setting, it's really nice to have these reports. If you're just calibrating for yourself and you've gone through the process, you know how you did it, you know what you did. But when you're working in that production environment, and we get this all the time, if someone questions like, well, wait, what's going on with this? I'm seeing a little bit of that. Well, let's pull out the report. Let's see how this tracked. Let's see where it went. Did it have an issue there? Did it not have an issue there? If it did, what can we do better with it? So there's a lot of things in Calman you can sort of do to go better. This is our pre-cal report, so you can see again that the color gamut is a little bit out there, and our delta E is not ideal. And then we've brought this in on the post-cal. You can also do that pre and post-cal comparison. Any notes you want to take on the calibration here? Let me go back. Any notes, you can make some notes. If there's this I actually love because I can tell a client if I'm calibrating for a customer, I can say, use this mode, use this setting. So if someone goes in and changes your brightness level or your luminance level, because sometimes people like to touch monitors, you can have it here documented and they can just go, oh, that's where it needs to be, perfect. Instead of setting up the equipment, making another measurement, going through the process again. Color checker. Again, once again, our post-calibration readings just made in a PDF report that you're able to output. And now I'll move on to the HDR. Any questions on the SDR process? Any questions on what I was going over there? I'm trying to keep it close. I'm also a bit hoarse. Okay. It's very loud, okay. All right, I will try to yell. All right, so once you're done with that SDR calibration process, you can go back, we have an HDR workflow, so you can go back into Calman and you can choose the ASUS HDR monitor calibration. We'll hit our start calibration. And it's going to be somewhat of a similar process, except HDR is a little more tricky in general to calibrate. So part of that issue with HDR calibration in general is we have a standard in high dynamic range that no monitor can achieve, right? Theoretically, we go up to 10,000 nits. No monitor on the market, not any mastering monitor can hit 10,000 nits yet today. There have been a couple prototypes at CES a couple years ago, if you guys were there. Sony had a really big prototype that ended up burning out, but no monitor can do it today. So when we calibrate HDR, we can't really go all the way to what the specification can do. So a lot of decisions have to be made of what do we want to do when we calibrate HDR and how do we approach that? And the engineers at Portrait have done a pretty good job of their color science and working through what does that need to be referenced? How do we get the most out of monitors? How do we make sure that we're tracking those standards the way we want to track them? Anyhow, so first we want to do the same thing we usually do. We want to connect to our monitor. Now, on an OLED, such as the PA32DC, OLED technology likes to have image retention. So what we end up doing so that we don't burn in the monitor, we don't ruin our monitor during the calibration process, is we end up putting a pattern insertion into the process. So it's going to put up a patch, then it's going to give the monitor a little bit of a break so we don't overheat the monitor. If you've worked much, I should say, in HDR, most HDR is not all the way up at the peak, right? The vast majority of HDR is at that lower 200 nits and below. But when we calibrate, we want to go all the way up to that peak. We want to hit that 500 nits, that 1,000 nits, that 2,000 nits. But we also know we don't want to stay there too long because we don't want to burn these things out. So we put in this pattern insertion so when we do make those measurements, we're not going to ruin the monitor. We'll connect to our meter again. We'll choose our OLED RGB. We'll connect to our pattern source as well. Again, I was in full range when I was doing this calibration process. Now here's where things get a little different. You may want to calibrate for HDR, which is the SMPTE ST2084 or PQ curve. That's your EOTF, right? Commonly referred to as gamma, but the electro-optical transfer function. But in HDR, we don't want to do that. We want to calibrate it to a 2.2 EOTF using Calman. And the reason we do that is because we can't track that PQ curve all the way, and the PQ curve is a bit per nit system. So a certain level of video needs to be at a certain nit level in brightness. But it doesn't really allow us to do that because we can't get up to 10,000 nits. So we would just run out of steam and the algorithm would just keep trying to hit more, and we'd end up clipping out our picture. We'd end up blowing out our pictures as we try to continue going there. So what we do is we calibrate to 2.2 because it's relative, and we go all the way up to the peak luminance, and then we do a 2.2 to PQ conversion in order to get the monitor into that SMPTE ST2084. So since we know what the monitor is doing and we've linearized it into that, we can then convert into that PQ curve pretty predictably. So here's a pre-calibration tracking in 2.2 gamma EOTF. Again, we're going a little minus blue. We've got a max error of 3.6 in this mode. And this is a BT 2020 color space on the CIE chart here. And we're looking at some saturations in the middle, around 50%. And we're a little bit undersaturated there based on how we are right now in the monitor state. We'll choose our mode selection. And here I chose calibration 2. And I did that because calibration 1 we used for our SDR LUT. So we went to calibration 2 for the 3D LUT in order to not erase our BT709 calibration, so I'm able to toggle between them when I'm done with my calibration. The Calman workflow walks you through the process, reset the monitor. That's gonna clear the calibration that's in there, get the monitor into state for our process. Check that your brightness is 100, make sure you've got the monitor in HDR mode, walking through these steps, and then we can measure white to make sure we're in that HDR mode, in that high luminance mode, measuring at least 500 nits or higher. If you measured it, and you measured around 100 nits, 120 nits, somewhere in there, you're probably not in the right mode. You want to go check that HDR, make sure that that's checked, maybe toggle the monitor. I didn't have any trouble with that, but things that you forget, things that you miss during the process. So it's really nice to check that measured white, because before you do this, if you're in a low luminance mode, you're just going to waste your time. Again, next step after we've cleared the monitor, we know we're in that HDR mode, we know that we're hitting that 500 nits, we're going to go to our auto cal process in Calman, and we're going to hit either a fixed 9-point cube, 13-point cube, or 17-point cube. The difference between these are how many points and how long it's going to take. So the more points you take, the longer it's going to be. For this demo today, we did a fixed 9-point cube. A 9-point cube means 9 by 9 by 9, so I don't know the math off the top of my head, so what, about 800 or so patches of measurement, and it runs through the calibration process, goes through those 800 measurements. It's going to tell you calibration complete, and then we're going to do our post-calibration capture. We're going to hit next and go into our post-calibration capture. And again here, we're going to see we're hitting our color balance the way we'd like to, from 0 to 100% white. We're tracking that 2.2 EOTF. We actually went from about 540 nits to the corrected 500 nits on the monitor. And you'll notice our color saturation was improved when we finished the process here. Now, oh, I should say, so now that was in the 2.2, that was our target in 2.2. However, I want to see what I'm doing in HDR, because the whole point of this is HDR. So what I did is, I put the monitor into that HDR mode instead of the 2.2 gamma. I said Calman to the ST2084 target in the settings menu, and then I remeasured it in PQ. So here's that conversion into PQ. Now what you're seeing here with this little roll-off is the roll-off against that PQ curve, because remember, we can't go up to 10,000 nits. So we have to do a conversion into PQ. And again, we're hitting our color saturation sweeps here. What you're seeing on this error around 70 is as we go into that roll-off. You're seeing an error in that roll-off. If you were to turn off our luminance calculation in our error metrics, you'll notice this is half a delta E and below, but I don't like to do that, because I like to see the whole thing. I like to see the luminance error and the color error. But the color error we can sort of see here, really, really tight all the way through, and then we can see we're tracking that PQ curve pretty closely as we go up the EOTF. Again, we get our calibration complete. We can do an additional validation. Here we are in HDR 2020. Here we are in the inside of that color checker, hitting our targets. Again, you're going to see that we have a little bit of about a 2.7 delta E, again, with that color metric. This is always a problem on any monitor out there. Whenever you're trying to track PQ, once you start to run out of the steam because we can't hit it, we start to get errors, and we get errors because we're down on our luminance. So it's something to be aware of. As a calibrator, you don't want to chase it. What you want to chase as a calibrator, if we go back here, the thing to chase is to try to track this PQ curve as close as you can until you get up to the point where the monitor can't do it anymore. And then the question becomes, when do I do my roll-off? When do I start to roll off? Because if you're looking at content mastered brighter, than the monitor you have, you're going to want to roll that off. You're not going to want to clip that out. In content production, though, you may want to clip it out because you're just mastering the content yourself. You're not going to be clipping anything out. You're mastering it. So you want to master that as perfect as possible. Then you put into your metadata, your mastering data, your encoded data. You're going to put in how bright your monitor was, how dim your monitor was, if the black is black, and you'll put in your color space. And then the next monitor will get that data and do its tone mapping accordingly. Say, oh, this was mastered on a 1,000-nit monitor, this was mastered on a 4,000 monitor, this was mastered on a 200-nit monitor, and then, oh, this monitor can do that, I'm not going to roll anything off. So it's a very intelligent system, but it also gets very complicated when we try to calibrate it. So there is our color checker, saturation sweeps. This is actually a P3 inside of Rec 2020. Typical production workflow these days is to work in the P3 color space, either inside of 2020 or outside of Rec 2020, because again, monitors can't quite hit Rec 2020 yet today, so we choose something that's a little more common. So we're tracking this P3 pretty well all the way across the board, as most monitors would. And again, we're seeing this here, these higher deltas here, because it's taking in luminance. We're not having a color error here. We're hitting our targets, but we are just not quite bright enough against the PQ curve. But I'm hopeful that in the next 50 or 60 or 70 years, we're going to be able to do this. If energy regulations do not stop us from going that bright, right? So, and there you have it. So there's also a program that we have that Portrait has made, our marketing department who's in the back here, called Color Matters. I don't know if anyone here has watched it. If you have, it's a great little presentation on YouTube talking about the production process and why color accuracy is important from the lens to the post-production suite, all the way to the living room. And it has a lot of great people in season 1 here. I think we worked with Marcel Photochem, right? Photochem on it. And there's some Industrial Light and Magic, Star Wars content in it. And the Green Knight is in it and stuff. And they talk about how they made the movies, how they made the content, what they were doing from a color standpoint, and why they were calibrating on the set, in the post bay, and trying to create that, trying to keep that artist's intent all the way through the production process. So I highly recommend you check that out if you haven't. That's about it. Any questions? I know it went pretty quick. It's a lot of stuff to take in.